Alex, your screen is just hypnotizing.
I think it's a good start like that, huh?
Yeah. So it's 10 a.m. Should we start?
Yeah, let's do that.
Cool.
So we officially started, aren't we?
Yeah, we're
awesome.
Welcome everyone.
Awesome. Welcome everyone. Good morning, good Saturday morning, and that's our fifth event, I think, right? It's the fifth event.
Yeah, number 5.
That's PizzaScript again, pizza time again. We have awesome audience, and we have awesome guests today. So yeah, let's introduce ourselves in a minute. Just after I tell a bit about what you can expect today. So we're gonna talk about PizzaScript. That's session number 2, and in this one, we mostly gonna talk about parsers, but not only. We actually gonna start with a little bit of pitch and PizzaScript as we did last time. And talking and remembering the theory from last time as well about programming languages and compilers. And of course, we will show some code and the current implementation of the parser algorithm. After that, I really hope to get your feedback on what should we do next, and I will give and will throw my ideas what's gonna be, for example, next event about. Before we do all of that, I just want to say a few words about our project, X Technology. That's educational programming, DevOps, data science, all kind of technologies project we do with these awesome people right on the screen. Yeah, I'm Alex, by the way. My project is called PizzaScript, and the goals for my project are to learn Go language itself, to learn about parsers, about compilers, programming languages, and practice with Go, of course. And for that, actually, we'd like to see more people joining, maybe contributing to our project. So if you're looking for mentorship, you are pretty welcome to join us. And overall, for the project, we perform these webinars or these live events, meetups, we call it differently. We also write articles, and that's basically our channel's content that we try to promote as much as possible to gather more audience each time. We also invite awesome guests and experts, like we said. Yeah, that's pretty much about our project. It's X Technology. We aim to learn new technologies together, share ideas, share feedback, to gather new contributions, to share knowledge about that, and yeah, have some fun in the end. That's what we do. So yeah, why don't you introduce yourself, Carlos?
Cool. Yeah, thanks, Alex, for the intro. I think I could go first. I'm Igor. I'm a data scientist, so I also have my project in our X Technology meeting. So yeah, my photo looks a bit different. Yeah, so I work in a company called Crayon as a data scientist and do different interesting stuff. And I decided that I should do even more interesting stuff. That's how we started this stuff with Alex a couple of months ago. Yeah, I will not talk about my project. You could go to our website and see what it is. So I'm happy to be here today, and I don't have too much experience in software engineering, so I will probably ask and make comments on a high level, which probably will also be nice. Absolutely. So happy to be here.
Nice.
Cool. So, Pastor Kirill, would you also say hi?
Hi guys, my name is Kirill. I've been working as a backend developer for more than 12 years. Last maybe 4 years, I've been working as Golang developer. I have really wide experience in backend and I would say software engineering. And I'm working now in Sphere Inc. And here I will be as a Golang expert.
Awesome. Thanks.
So-
Thanks a lot for joining today.
Thank you.
Hi guys, then it's just me left, Sebastian. I'm also working for Crayon. I'm a solution architect for machine learning. So I'm also a little bit more on the data science side than on the engineering side, but I'm really excited to learn more about your parser PizzaScript. That's gonna be fun, I guess. So I learned a lot.
Thanks. Thanks a lot.
Yeah,
Wow.
thanks for joining, guys.
Yeah, thanks for introduction. I realized that I may say maybe a few more words about myself. Thanks for joining. We also missing our other colleague Andrew. He has also nice experience with Golang and DevOps, but unfortunately he could not join today. So a few words about myself. I'm currently located in Netherlands, and I was doing software engineering for quite a long time. But my former experience was related to JavaScript. Now I switched for Golang and Java, and that's my homemade home toy project to basically practice Golang, so to become more expert in that, to gather better skills in that area. Nice. What should we kick off? I think we should. So PizzaScript.
Yeah.
And last time we said already a few words about that. So some examples. So my goals for the project, like I said, to learn Go language, and I always thought that it would be a nice idea to actually introduce some Lexer or parser. Well, that's to parse some text, and maybe programming text is the easier to parse. So yeah, that's how I went with this PizzaScript experimental language, like I said, and I always wanted to combine it with a ReactiveX pattern, which is a pattern for events, for asynchronous events and asynchronous data flow inside the application. And I had an idea that it actually would perfect fit the parsing paradigm. And we will see in the series of these articles how it goes, by the way. But I already got some feedback, and I've got some summary myself. But let's get to that on its order. Also, it's very nice to back to these programming languages in interpreters and compilers theory. And in fact, I have a computer science background, but I didn't touch this matter for, I think, like 15 years or something like that. So it was it's still a very, very difficult journey to me to understand what's basically the difficulty of making your own parser or making your own compiler. And that's how I hope you will also, I can share something useful to you if you're interested, of course, in writing a compiler or practicing Go language. And the last point in here, which to be honest, I hope to demonstrate next event that we're gonna perform, next PizzaScript event, a little remark here. So our goal for PizzaScript is actually to compile it eventually to WebAssembly, and that's why it's sometimes called a compiler. We have a question about that, to be honest. So next event probably is gonna be about WebAssembly, but again, let's go in our order. So first, a few words about PizzaScript. Well, of course, it has an awesome name, as we know. That's one big feature of this language. Then I thought how I gonna construct the language, and that's actually very, very difficult question. So I started with writing some examples, with of course with reading some materials, and this slides or this presentation that you can see on the left side of my screen is containing some pseudocode, and I decided to write it in a PizzaScript language itself. It's very alike JavaScript. I think you will not have any difficulties in understanding that, because the exercise is not that difficult, to be honest. But yeah, it's like JavaScript with some smaller adjustments, and in fact, that all is not yet existing in the implementation side. So let's go through these examples quickly. First, I really I'm really not familiar with Kotlin. I actually use it a little bit, but I am not in any way an expert in that language. And that's where I just touched the Kotlin language. I was seeing the first time the var and val operators to define variables, and that. Yeah, I mean, the variable and value, that's what the operators var and val stay for in Kotlin and also in Scala, like I understand it. But I think people mostly agree with the point that it might sound confusing. So I decided, why not to bring it to PizzaScript? PizzaScript is already confusing. So yeah, that's the first example here. We did define some variables. The first line in here is actually showing some other nice detail, which is a standard library for PizzaScript. Yeah, I like to talk about this PizzaScript because it's basically an abstraction that lives only in my mind, and that's still not yet implemented. But the idea is to also have a standard library with some functions that a user or the user of this language can call, and for that I use this straightforward interface. Basically export something from standard library, and then you can use this print function from here. Yeah, that's a combination of syntax like we have in JavaScript and also in Go itself, I would say. But as I said, this is under development. That doesn't exist yet in a real language. That's just the constructions that I'd like to have in the future. So yeah, we defined some variables in here, and as you can see, I decided that I'd like to have a dynamic type language. So for that, you can actually define your variables with a type like here, and that syntax also is common used between different other languages like TypeScript. That comes to my mind first, but yeah, I think it's not the only one. Also, the dynamic typing would mean that you basically can reassign different values to the variable. It's not in this example, but probably we will see it somewhere in a later one. Also, interesting part in here is that yeah, I just wanted to say a var and val. So the first one shows that you can reassign a value to that, and with a val operator you cannot. So yeah, be careful. It's sometimes confusing, but yeah, but still it's used in Kotlin and Scala and many other languages, these operators. So you might see it in the future or in your programs that you write. And then I decided that other nice concept that I'd like to have is a hosting. Hosting is a nice concept that I borrowed from JavaScript. Basically, the idea is that you can use a variable that was defined somewhere below in the code. So yeah, that's how it can be shown. Like first I assign some value to the variable that we don't know yet. Then I print it, and it should work. And then I just define it like that. And you can see that the var and val not used in here. That also indicates the dynamic nature of the language that I'm trying to construct. And even more, you can control if you want to have a hosting feature in your language or not. Yeah, that's kind of idea I'd like to have in my language. And also it's borrowed, I think, from the TypeScript, where you can specify the compiler options in some JSON file close to your project, tsconfig in the TypeScript world it is. And the last one to talk about PizzaScript itself is an example that demonstrates factorial. One of the classic examples in a programming language. So in here, I again export the print function from a standard library of pizza.io print. Yeah, just it's fun already to talk about that. So yeah, we define functions with a keyword fun, and then you can define arguments in these parentheses in here. But one of the proposals for PizzaScript I defined file of this project is that actually you can avoid parentheses as much as you want, as you could. So in some cases, let's say parentheses are not required. I still didn't formalize it, but that's what I tried to achieve at least. And as we know in Go language, for example, let's have a look at the line here. Actually, if and else statements, and if I'm not mistaken, also while statements, yeah, might be mixing it. Probably Go doesn't have a while, but a for cycles. The condition basically doesn't require to have parentheses in there, and that's what I decided I also want to see in my language as well. But this example shows that it's perfectly fine to either use it or not to use it. So in some cases, as you can see in this arguments, I use the parentheses to identify arguments, but I think it wouldn't be required. However, I can already see some troubles with the grammars to construct this language. But let's keep it for now. We're gonna explain grammars a bit later. So what is a factorial? It takes some argument that should be an integer, and then basically if it's a 0 integer, I should just return 1. Otherwise, I should recursively call my function with the argument decremented by 1, and that's what happens here. So in here you see a call of a function factorial without parentheses. I thought that would be indeed nice to have less and less parentheses as it's possible. So that example shows how it would look like. And actually in here, I also show how to make a cycle without parentheses. So you print multiple arguments in here without grouping them, let's say like that. But that's how what I desire to have. And that's not what exists yet. So what exists right now is this small program that is a compiler, the interpreter actually, for simple calculator use case. So what that means is basically I can pass different expressions, well, not expressions, some arithmetic operations in here. And last time I think I already showed some of these. But what it didn't support for the last time was something that is called the prefix operators, or maybe the other way of naming it or talking about that is called null context denotation. Yeah, that's very very confusing term, to be honest. So that kind of things were not supported last time, and now they are. Look at that; it just works fine. You can basically say that minus plus 2 is pass it to the compiler or to the interpreter of PizzaScript, and that will produce the value of it. That's what it is. We actually can look at these examples even more, but I think that's kind of enough to show for now. So guys who have been here last time, I maybe looking into Igor right now. I have a few questions to you, but also maybe Kirill or Basti can answer some of those. It's also nice to hear answers if you are not completely prepared, because they will demonstrate how clear these concepts are, even without you learn them or without you reading about them up front. First question that I have to you is, what do you think is the difference between the interpreter and the compiler?
Awesome question. Actually, I can go on because you know more.
Okay, I thought Igor wanted to say that I had some question. You said about hosting, and I want to ask you, what is a practical profit of late declaration of variables and so on? Which useful thing it could give us?
Yeah, good question. I think the simple answer is nothing. that's I think what it is. Well, yeah, I think JavaScript is that all comes from JavaScript. I actually don't know other examples that are using hosting. Maybe I can look into the search in Google. I think JavaScript is a simple language in a way that you can write almost everything in there, and that would not give you an error. And actually, you will write working code. I think that could be a benefit of it, but I understand and I realize that that gives more drawbacks than actually benefits in this case. However, in my whole experience as a JavaScript developer, I did not see many difficulties or problems using hoisting myself. Like almost never. Like many people that come from a side, from strict typed languages and from compiled world, like from C, C++, they think it's a nightmare. But in practical aspect, I never saw a problem with that, with this. But yeah, you might agree or not. I don't know. That's actually very interesting to hear about.
Yeah, and I assume that it is something like tricks or hacks of interpreters and so on, and something like type hinting in JavaScript and nightmare with type hinting in JavaScript.
Yeah, why not to call it like that? That's fine. So shall we back to the questions that I have?
I had some time to Google, but I tried to be fair. So honestly, that also was one of the questions which I already typed to ask you, but since you're asking me, well, as I understand, there are interpretable languages and compiled languages. And when there is a compiler, then when you try to compile it, then there is this instance. The compiler, it goes through the code and tries to turn it into machine code right away. So it looks through all your program and tries to check whether it makes sense, and already turns it to the machine codes. And the interpreter, I suppose it does it not right away, but just at the moment when it gets to the, I don't know, function or a class or whatever. So it doesn't look at the whole program at once, but it tries to do it step by step. That's my interpretation. Although probably there are some checkers of syntaxes before interpreting. But
yeah, it's all good, Igor. It's very good answer, I would say. Anyone want to add something, maybe?
So I got this right. Interpreter is you go step by step, basically, and interpret on the way, and compile is the other way around. So taking the entire thing, and then evaluating it step by step. But first having the entire thing, right? And the entire code.
Yeah. I think those sensors already show us that this concept is very known, and even for people. No offense, but as you said, you are not software engineers, but it already shows that that is. At least you have some basic knowledge of what it is, and indeed, the compiler, and Igor said the right word, compiler does it ahead of time, and it produces a machine code that can be straight away executed by a machine, basically. And the interpreter, it might have some intermediate representation of a code, but it might have some ahead of time, again, a step to analyze the program and if it's valid or not valid. But the point is that it doesn't produce this machine code, and it just interprets the program or the intermediate representation of a program, going sentence by sentence of this program and executing it. That's just one more remark. This is a very broad question, as you can imagine, and there are no right answers for that, because you can go deeper and deeper, and that would basically make more and more mistakes by that. But so I think let's not spend too much time on that.
Alex, maybe just one thing. I could maybe one question to check if I understood it correctly. Interpreter, for example, would not be able to do, you could not do hoisting there, right? Because that would not be possible because you specify it further down in the code. Is this correct?
Not really, but that's a very good question, Basti. Yeah, indeed, hoisting. I think it shows that hoisting is itself a very weird concept. That's why it can be felt like that, I would say. I think interpreter can still do this calculation upfront, right? And see what needs to be hoisted before executing it. So the step when the compiler, both these programs, see the program first time and already analyze it and see what to be see what needs to be performed first as operation. And in case of hoisting, the interpreter can actually put some operations before the usage in here. So yeah, that's a part that we saw in here. Basically, the interpreter and the both compiler as well, they will look at the whole program, see the whole text of it, and then basically decide you as a user or as a developer engineer put your definition of a variable down below. But interpreter should not execute it right there. Right? You still it operates on some, or it may operate on some intermediate representation where it already did some conclusions like, oh yeah, but I should declare this variable, or I should take a memory for this variable before actually I use it. So it's absolutely up to the program that is called interpreter or compiler. Or not necessary in short.
All right.
Yeah.
I assume that it will be quite tricky to implement such thing, and in compiler language and in interpreter language. Yeah, and I wanted to add some thing about interpreter and compiler languages. That compiler languages, you have binary, and you have already compiled machine language. And when you use interpreter languages, it interprets it in machine code on the fly, and it gives us some performance issues. And because of this, we have some just-in-time compilators with the cache and so on to improve our performance.
Yeah.
Great.
Yeah, that's very nice, and deeper details on that. It's thanks, Kirill. That's nice. Okay, shall we move to the next one? Yeah. I think that was one of the most difficulties in the equation. So the next one is quite simple. Do you guys remember maybe last meetup we had? What is a token in this whole material?
Well, I suppose it's some word or a number. So, I mean, you have a string, and then you split it on tokens, and split it based on some punctuation, I suppose, or spaces. This one I'm not entirely sure.
Yeah, absolutely. Yeah, Igor, that's right. Well, in addition to that, I think you used the correct notion of it. But in short, the token is something like that. It can be very simple data structure which has a type, well-defined type inside the interpreter or a compiler or in any other program, and a value of it. And the value indeed can be, for example, a number, like an integer number, can be a float number, can be the whole string, the big string, for example. And the point, you also said it correctly, absolutely, that the token comes out from the first part of the compiler or interpreter, doesn't matter, which is a Lexer analysis, or the Lexer itself. Basically, it takes the whole program text as an input and produces these tokens. And the idea is that from the text, you do the first iteration, and you split it into, and you analyze them into something that the program already knows about. And something that a program knows about is the token and the types of a token that exist and defined inside the program. So all good. Okay, how can we specify language? That's a very broad question. Anyone want to answer that? And by the way, if we have someone watching us on YouTube, please feel free to share your questions or post your answers as well. That would be interesting to hear about.
Yeah. How can we specify language? So I suppose we need some set of basic entities. So probably the mentioned tokens. So the set of all the tokens that could be possible in this language, and also the rules how to connect them. or how they should.
Yeah, I'd like to hear maybe Kirill. Kirill, do you have an idea how can we specify a language, a programming language?
On line 46, you have answer on this question.
True. Yeah, that's very sharp. Yes.
We have to declare some keywords, key things such as function, var, values, and so on, and we need to parse it.
Yeah.
We need to find these keywords, and as you can see on 46 line, we need to map some keywords to some functions which will be work with these lines.
Okay, it's a practical vision on that question. Basti, if you have something to add, please please shout. Otherwise, I can try to explain it. Take it as a no for now. Yeah, this is a very that's basically a very academical matter, and I'm gonna talk about the real answer in right here in a few minutes. But I like actually the second option answering this this question. I saw it well. So far, I don't have like a strong knowledge on this area myself, but yeah, I spent some time on that and trying to get more and more knowledge. So I found this short answer to this question, which is to write a compiler. And the compiler can say, yeah, is this program of this language, or it's not valid in this language? Yeah, I think it's perfectly defines a language, a compiler that you build. Yeah, I mean, it's not a trick. It can be indeed the definition. And also, it's a very abstract question, so you can define a language in many ways, I guess. But the theory is about one way of doing that, and the theory is a very is based on some theorems, and it's based on some definitions. But yeah, you can do it in like, for example, if we're not talking about programming language, it can be natural language. And a natural language, how it's defined? Well, it's not defined at all, right? It just exists, and that's the key. Okay, next one. That's not that hard, guys. What is an AST? Who does remember that?
It's an abstract syntax tree.
It is. Awesome, man.
Do you have some prizes for right answers? I have to explain what it is, right?
No, not necessary. That's already good, but maybe someone has some addiction to that. I don't know. No, doesn't matter.
I guess with this tree, with this tree thing, it depends very much. And I'm not like a very strong expert in that field, so I would like this is related to, is this a top-down or bottom-up approach, right? And then the tree might look different, right?
Yeah.
Or in the bottom-up, yeah. Mm-hmm. Okay.
Yeah. That basically this indeed, like Basti correctly mentioned, is the output, or can be the output of a second phase that we are about to talk right now, is a parser. And the parser can produce this abstract syntax tree. And in short, also, it's a representation of a program in some intermediate style or intermediate way. And it can be a multi of them. And I will show. Let's show it now. Actually, the IST Explorer. I like this link. It's an awesome one. So this is this one shows different types of IST. So on the right, you see some structure. It's nested and it's hierarchical. And best of all, it's not defined one for every language, and basically everyone can create its own abstract syntax tree. It's not something that is written in specification, however it can be, but not taken by everyone. So this web application in here, it demonstrates how you can first write code in any language that is known to this program, and then you can produce the abstract syntax tree using different parsers. And mostly I see JavaScript examples, but not necessary, right? It also can produce IST of any other language that we can see in here. Babel is, I think, one of the well-known to JavaScript community. Acorn is actually part of Node.js itself, so let's use Acorn. Why not? It doesn't matter which one we use. So yeah, that's how it works, right? We put some input, and it produces some tree in here. And basically, the idea of this is that it shows a program in the intermediate representation, and in this case, it's just a JSON. It can be treated as JSON, but some nested data structure that contains information about our program. And the idea is that you have all operations, all expressions, all statements are in some way represented in this tree. So yeah, I hope that clarifies it a bit. We should not be very strict and very right in answering that yet. In my PizzaScript current implementation, the AST is built on a very, very simple type. It's this type that you can see on the right. It's by the way, it has a term. If you make an AST based on one type, it's called a homogeneous abstract syntax tree. That's what I did. I didn't know that before I read about it, but I already implemented it before. So I have just one type of node that can exist in this tree. So on the right, you can imagine that instead of having a program type, I will have a node in here, and each part of it can be also a node. The left part can be a node, and the right part can be a node. That's how it looks right now. I mean, it probably would be refactored in the future. All right. So how does it feel? Are you ready for the last one, or should I just go and kick the theory a bit? What's the difference between the parser and the Lexer? Igor? No.
Well, the parser parses, and that's the first step, right? So it's
true story.
Text and splits it on tokens, I suppose.
Tokens, yeah.
Maybe not tokens. On some
tokens, yeah. Lexers or tokens, or lexems actually, yeah. Indeed, that's almost almost does it. Yeah, and also, like we said, I think already, the parser can produce the abstract syntax tree. Not necessary, but it also can just answer the question if the syntax of program is correct. So it also analyzes the program, but instead of in opposite, what a Lexer does, Lexer splits the input into the tokens. It can also produce an errors if a token, for example, is not recognized by this piece of program, right? For example, if we don't support, I don't know, some extra symbols, emojis, for example, we can throw an error already on a Lexer stage. But usually Lexers are supporting many different encoding, and yeah, it's all just passing through the Lexer. But on a parser stage, you can already check the syntax of a program. Like if you wrote some colon in a not correct place, that's where the compiler can throw an error to a user. Okay, let's continue then. I don't wanna. Yeah, thanks for answers, guys. By the way, it's very. Yeah, Igor.
No, go on.
Okay. Yeah, I think we all refreshed pretty much the knowledge from the last part, but let's just quickly what I wanted to mention here. So how do we define a language? Basically, you can do it in this science way, and that's basically you start from a lower definition. So you define an alphabet of all known symbols, and the chains or phrases in this alphabet, they form a language. Not all the chains of this alphabet, not all possible strings that you can produce from this alphabet form a language, but some specific set of these phrases form an alphabet, and that's basically the definition of a language. So you just say, yeah, my language is sentences, and then you make like I don't know, infinite number of sentences. You just put them into this set, and that defines the language. Yeah, like I said, it's mostly languages are infinite in that matter, and then you need some way to define this language. And the scientists that they came with this nice representation is called the backwards nar form, and it actually has some extensions, extended back nar form, for example. So basically, it looks like that in here. It's on the left, you define some non-terminals, it's called, non-terminals, tokens, you can say. And on the right, you see both non-terminals or terminals. And the terminals, you can distinguish them because they are constants in here. So those terminals, and they are called terminals because they cannot be transformed to anything else already. That's the final state of this phrase or word. So yeah, that's how you define them with a simple set of rules. And the rules are having some limitations. And basically, these limitations can vary. And by varying these limitations, you define different subsets of languages. Like maybe you heard about languages that I don't even remember it now. Like languages that having a recursive structure or something like that. Let's not continue in that direction. I would not do that. The more limitations you put on that, the easier that would be to produce a compiler for this language. In general, of course, that's because the limitations can be absolutely different. So in here, I actually had different versions of this grammar. It's a grammar defining the calculator case that is currently supported by PizzaScript. And I found another web application in here. It's Bnf Playground. Basically, it you can put some grammars in here, and it below underground on the hood of this application is something like that I'm writing in a PizzaScript itself, but it just produces a bit different result. So it parses these rules and it generates a parser. By the way, the generated parsers are very common in a software engineer world. I can name NTLR, for example. It's a very well-known generator for parsers. It's written in Java, by the way. This parses the grammars, and after that it can produce the sentences in this grammar. So that's very nice. And actually, it's nice to see that you just can produce many of those and check if my compiler actually supports them. So I really like this application here. So these are the grammars, and like I said, you can also make just write your compiler, and that would also define a language. So yeah, it's a very, very broad question to answer. And then we have a Lexer, which splits the input into tokens, and then a parser takes these tokens already as an input. So you can see these programming languages programs, or parsing programs or compiler programs, they are structured in a way like in different stages, and every stage takes an input as an input, the output from a previous stage. And in a compiler world, most known stages are Lexer and Parser, and the last stage you can say the compile or eval or interpret stage. So that already depends on what we want to achieve. So in my case, in this PizzaScript, in the current example, I actually built an interpreter here. So I produced the IST, the parser, the parser phase, and then I already also interpret it, and that's what you saw in a console, right? Because you saw the result of this expression that I passed as an input. So it also interpreted this. It didn't produce machine code, but it interpreted that. But as we said, the goal is to produce actually the WebAssembly bytecode, and that's not machine code, but that's a very, very deeper matter. So that I would not focus really in this definition of what is difference between interpreter and compiler, what kind of code it produces. Is it a machine code, or for example, to me it sounds like it can be a compiler named that produces just WebAssembly and then executed by WebAssembly. However, in a tradition articles, that's of course called the interpreter, but in this way, interpreter is on the side of the WebAssembly itself. WebAssembly we're gonna talk not somewhere in the future. One last thing before we talk about parsers. I'm looking at the guys because I promised them that will last not more than 40 minutes today. That's interesting. Yeah, so one last thing about the project, I wanted to say that I decided to use Go language, and as I said, I always wanted to try the RxGo, the ReactiveX concept, and the Rx library for that, because I thought that would fit perfectly. Because basically, this idea that you take stages and you consume the output from a previous stage into this stage, I think that on that high level, the idea is very alike or very similar to what RxGo and other reactive libraries do. They create streams of data, and basically then you can combine these streams of data into different flows, and that will give you the result, the desired result. And I actually have a goal to specify what benefits can bring the ReactiveX pattern into your program, and that is, for example, unified API. So you use well-known operators and that you can combine streams with. You have basically you know how the data flows, so you unify most of your data flows operations in the program. Yeah, that's what I wanted to underline here. Now about parsers. I tell you guys that that would not last for long, but about parsers themselves, so we said that there is an idea of IST, and the parser stage produces IST. We look at the IST Explorer in here, and then the question is, how do you produce this abstract syntax trees from the tokens, from the just stream of tokens? And it seems that there are almost infinite number of algorithms that can do that. And as I said, even the generated parsers can be used. Like you can pass the grammar, like we saw before, into the program like NTLR, and that will produce you a parser that actually will give the abstract syntax tree for any input in this language already. That's that's nice to know. And many articles that I read, they say that of course it's nice to generate your parser from these kind of programs, but if you really want to learn it, then it's better to start with writing it yourself. And then basically it also has some benefits if you write it manually against the generated one. In many cases it can be faster, for example, or it can support many other things, and maybe extension of your programming language, for example. So let's note about generated parsers here. So I started that we have multiple algorithms of producing this IST from tokens, and also wanted to mention that this material or this theory was developed in 20th century mostly. I think it all started in somewhere around 50s, and then most of the theory parts were covered already up to the 80s. So at least for now, I didn't find many improvements on that matter. Well, of course, we have now nicer tools like NTLR that can produce these generators, parsers generate these parsers. But I think in terms of theory, that didn't develop since last century. But I'm still trying to read more about that and find more material. So parsing algorithms, two big categories of that. One is called top-down, the other is called bottom-up. And we are going to talk about top-down mostly. So the top-down is the way that you start by parsing these inputs as you want to see your as you want to see your program is compiled to. That's very hard to explain. So I will just open the Wikipedia. It has a very nice example of this top-down parser, or it's also the recursive in here. They use this grammar of Scala-like language. It's not very big, as you can see. And actually, that almost obstructs the whole language itself. So you see, these grammars are very powerful themselves. And then, yeah, how would you make rules to transform your, again, tokens into the abstract syntax tree? So recursive descendant parser goes with the way that for every left part of these rules, which we know is a non-terminal token in here, you make a function which basically implements the right part of a rule. Yeah, this right part can be non-terminal, and if it's non-terminal, you call the function that is produced from this rule. So that's why it's recursive and it's top-down in this way. So you start from a top, right? You say, yeah, my whole input is a program, and what is my program? It contains some blocks, and it can be splitted by dots, for example, in this case. Yeah, so that kind of what is the approach for writing your own recursive descendant parser, and I think in this way it can be also generated very straightforwardly. Yeah, the idea is that indeed this is very straightforward algorithm. You take a grammar, and for each left side you produce a function, and for every right side you make an implementation which calls the functions that are defined below in this grammar. So I think the concept is very clear, and this is implementation. It's almost final implementation of the grammar that we saw in above, right? Yeah, I'm not sure how to show it nicely. So if we look at the statement, for example, in here, statement is quite difficult, to be honest. What shall we take? Maybe expression. Yeah, expression sounds good. So if we look at the expression, what it does here, it checks, oh, if my current symbol is a plus or a minus, then I will take a next symbol. Then I'm gonna check if my the next part is actually the term, right? And I do it by calling a term. That's what it does. And then basically where was it? In here, I go with a regex expression defined in a grammar, which says it can be any number of that expression. So I just produce my while loop in here, and I do basically the same. Yeah, I do it while my symbol is plus or minus, and then I take the next symbol and I check if the next symbol is a term. And that's yeah, I think that's a very straightforward way of making your program based on this algorithm. So that's I think that should be clear. Yeah. Again, we take a left part, we define a function that is kind of called like a left part, and the right part we implement as a body of this function, which is if we see the non-terminal, we call it, and if it's a terminal, we just use the language functionality that we currently use for making our parser. Yeah, like we saw in here, we created the while loop or the for cycle to actually make this regex be valid body of a function. That's what I explained in here. The left side is a function, the right side is a function body, and the quantifiers and other regex kind of expressions in a grammar can be translated into the language details. Yeah, that's kind of what the recursive descendant parser is about. The alternative is basically to make a bottom-up parser, and the difference is that you do the other way operation, and it's also very difficult to explain it, by the way. So instead of doing from top to bottom, you don't start with a program in here. I think the idea is that you kind of transform it all from a bottom to the top. I would not even start explaining that right now. The idea is that you're gonna switch the rules, and you're gonna turn the rules in the opposite direction, basically. And I didn't use it myself, this algorithm. So yeah, let's not explain that. So, like I said, this is very complicated matter itself, because it was developed in the 50s, and I think no one, well, maybe there were some scientists who are working on that, but not much updated since that, and the algorithms still stay the same. So what I found a kind of funny example of funny quirk is that this Pratt parser that I actually used to make this example here, it's called the precedence parser, or top-down operator precedence parser, based on recursive descendant. And then in the same article on Wikipedia, it says that operator precedence parser is a bottom-up parser. So you see, it's very, very confusing sometimes, this categorization of algorithms. But yeah, that's not the point. Anyways, we want to just build something that is working in the end. Yeah, so we saw this recursive descendant parser, and I think the idea is straightforward. We start from the top. We make some grammars to real functions construction, produce functions. Yeah, it's all good, but it has some drawbacks. And the drawback is that if you want to make your compiler to really be performant, and also to be stable, and not just fail, but also do some useful stuff, it would be harder to maintain this code. Like imagine you extend somehow this grammar, then in these functions you need to make changes in every function that is involved in a grammar, and that can be a nightmare. At least I think so. So it seems that there was a guy Vagon Pratt, I think it's called, and he proposed an algorithm that has the same idea, but does it a bit differently. So the idea is very simple in here. The whole algorithm can be described in this kind of cycle. So instead of having implemented all of these grammar rules, or the grammar rules one by one function in here, it says, yeah, I'm going to assign the specific parsers as I'm going to create these functions anyways, but my whole algorithm will basically be encapsulated in one just a small expression function, and this expression function will work like that. It will take try to understand the language by separating into the two parts, the left part and the right part of the expression. And the left part is called the null denotation part, or no left context part, and that's what I showed you in the beginning, how that differs from the let part, or the in-between part of the expression. So it can recognize +1, -1 expressions, and so on and so on. And the right part is a let, basically. So it's based on what was produced from the left already, and it will understand if this operation is valid on the left operator and on the right operator and the operation itself. Yeah, so for now, it's maybe not very clear. In this concept, we first try to consume as much as from the left to construct our left operator, and then we go to the right, and we will produce the tree like that while going to the right. So immediately we already produce the IST while we go into the right. So these left or node operators or functions, they produce some kind of tree already. All right, a few more words. So in this is very simple cycle in here, and it has some problem, and the problem is the precedence. And by the way, the grammars has a precedence idea. So these guys in here, they have precedence, and the precedence is actually expressed in the order of this all groups, I think. So yeah, it's kind of intuitively known that every language has a precedence. Like you can expect that your mathematical operation or mathematical value of this input in here would be 7, right? It shouldn't be 9 in this case, because if you don't have this precedence, it would be 1 plus 2 3 to us, and then it will multiply, become 9. And that's not what you want, because you have this idea of precedence. This one has more priority than the left one, and that basically breaks this loop. So that's why this loop would not work in this form. And that's why we have a second iteration of this loop. That was basically proposed by Pratt. So he made a very small adjustment to this function, and the adjustment is the introduction of the function that is called BP, binding power. No, we're not paid by BP brand here. So the BP basically has a value of the precedence. So it knows that the multiply operation has more weight than just a summarize operation in here. And what it does, what the adjustment does, it basically says, I want to consume everything from left to right until my current binding power is more than the right binding power. That's basically what does the trick in here. So yeah, let's have a look if I have this. I think I don't have this example, but the idea is that if we go in 1 plus 3, then we will start producing a tree in here, and then we are gonna switch to another recursive call, but with the other binding power, which is bigger than we currently have, because this function will see that the current binding power is or should be, the multiply operation binding power should be bigger than the summarized one or the default one. So it will call the LED function eventually, and the LED function will call recursively the expression again, but now with the binding power of my current operator, and it will return back only when the right binding power is less basically than the current one. In this way, we gonna group operators on the run basically, and we gonna group this into the trees on the run, and that's basically the idea of this parser itself. And as you can see, this idea is it's kind of clear. However, it's a bit less understandable than the just recursive descendant that we saw before. But still, in this shape in here, it's kind of not big, right? It's just a cycle which has an idea of binding power, and it consumes everything from left to right. If it doesn't have a context, it will just produce a simple tree node in here. So +1, -1, +1, blah blah blah, and then it will take into account the binding power of a current operators, and it will grow our tree depend on that. So far it's not that hard. And that comes into implementation side with the RxGo. That's last part of this stuff. So take care. We're almost on our finish line. So the problem with the RxGo that I experienced so far is that you want to the RxGo itself is a functional technique, and the functional technique in programming languages basically means that you want to stay immutable. Well, it has more concepts, but you want to stay immutable, so you don't want to modify the current value or the current pointer, for example, the current object, and it should not have side effects. And that's what I tried to achieve with this RxGo as well. However, these recursive descendant parsers and also Pratt implementations, mostly they just use it in the best way they can. So they are not using the functional paradigm, the functional programming paradigms. Yeah, and also the other thing that the RxGo library brings into the implementation in here is that I cannot directly call this the nested expressions. So you can see I call the let, which should produce my chart in here, and the let operator will also call the expression in here. So it's basically the recursion. And in RxGo, you have an idea of these streams that produce events asynchronously, but there is no such way, or at least I don't know yet how to make it absolutely fine with this streams concept, that you can call directly something down below in a recursive way. And that's what brings troubles in the implementation in here. So in our top side of this function that does all the algorithm on the left here, this one is basically the node part. So that's what you can see on here. I just produce a left part of my expression. I do it by using the scan operator. And the scan operator, let's maybe have a look at that one. I will open it in browser. RxGo scan. Yeah, what it does in here, this is a marble diagram, so you can see. It basically it behaves like a reduce loop on every iteration. So what it does, it can keep the value of the last operator of last function called inside this scan, and that it produces what you specify as accumulator. So you know the previous value of what went through this cycle. So for the first one, the accumulator value would be 0 because nothing was given. And for the second one, you will get the accumulator value which was produced by the first iteration of a scan, and also you will get the second value itself. So you can decide what you're gonna produce in this loop. And in the third one, you will get both the next one, the blue value here, and also what was produced on the second iteration in here. So that's basically what enabled me this recursion flow to happen. And I just needed to implement in a bit different way. Instead of doing the recursive calls, now I grow my stack of these calls and store them in accumulator value, and that's it's one step ahead from the recursion technique itself. So what the recursion or the function call does in every programming language, basically, when you use some function call, it creates a new stack. I'm not sure, new stack item, and it can create something that is called scope to store there some local variables, for example, to produce some values. And then when the function call is over, it will back you to the previous allocation in your program. And that's what I had to implement myself in here, because I cannot use recursion itself because I don't have a link to recursion here. I don't even control on which index on a program input I am in here. What comes into this function comes asynchronously, and because I don't want to use side effects, I don't know what was before unless I use the accumulator value in here, and that's what I do. So I store this local stacks, and I store them in my artificial stack. I had to create this intermediate representation myself that basically contains all the operators and values that I needed to know for the previous iteration. To be honest, I think I should finish the explanation in here, and I can imagine there are some not very clear things so far. So I'm eager to know your feedback on that. So guys, any feedback so far? Any questions you maybe was not explained too well?
Yeah, well, thanks for a lot of things which I didn't know before.
Mm-hmm.
I honestly wanted to stop at some moment and ask some questions, but I was a bit late. Yeah. So anyways, I think I mostly have kind of superficial questions, not going into deep details. So maybe Kirill has some more technical and programming questions. and then I can jump to my.
Yes, thank you, Igor. Thank you, Alex, for presentation. And I have a question. I assume that you started to this project to learn how to use and how to write using Golang. Am I right?
Yeah.
Yes.
Correctly.
And instead of using the main features and the main the main things of language, you've used ReactiveX. You've used a pattern from other language, and it is something like accent in our speech language, and you came in Golang with your own accent. I assume you are a JavaScript developer. In my practice, I saw a lot of different accents in software languages from Ruby, JavaScript, PHP, and so on. And in Golang, the main pattern is channels. You could use streams and so on. It's quite a bit complicated thing instead of ReactiveX, but it is really a sync pattern, and you have to synchronize your channels and so on. And this is really a good challenge to rewrite ReactiveX application to your own channels, your own implementation of channels and so on. And if you rewrite it using channels, you've lost some issues and hacks, for example, interfaces. And this is one more thing which is not good in Golang.
Yeah, cool stuff. Thanks for mentioning that. Yeah, indeed. So a few things from my side. So yeah, indeed, the reactive. Yeah, I'm actually not sure historically what world comes the reactive patterns from. Yeah, it's very developed in JavaScript indeed. So a few things about that, like I mentioned before, indeed, I thought the idea of streams, of asynchronous streams, and the ReactiveX's implementation on that, I thought that would fit perfectly the parsing strategy, because you basically what you do, you do some calculations on on the values passed synchronously or asynchronously. In this case, is actually mostly synchronously. So that part of ReactiveX doesn't make much sense in my implementation. I agree, but I knew it from the beginning, I think. So second, I wanted to mention that indeed this channels idea. One thing I don't know. Do you know that actually this ReactiveX is built on top of these channels? And I think it's quite a big step forward from channels. I mean, in a way, if you want to use these unified operators, and you basically want to switch from one implementation that you already use this operators, so you know how to combine them properly. So I thought that actually would make a total sense in here. And now,
yeah, I know that it is wrapped around the channels, but we have a lot of interfaces here, as you could see, and one more thing is this library is not quite popular in Golang community.
okay, yeah, I'm curious to know actually about interfaces. I had the one question I wanted to maybe ask you actually. Like, indeed, that's I saw it in some Google resources that yeah, basically it's kind of bad practice, right, to use interfaces everywhere, right? I mean, in the argument or in the return type. Is that correct? Is it the bad practice?
Yes, these things such as interfaces or reflect, it is quite exception things for quite exception situations. And usually, if you could type some, this is strict type language, and if you could type your arguments, you should do it.
Yeah. Yeah, to be honest, I also saw it in one of the parts when I was implementing this thing here. My node function basically returned different times because it had to operate mostly interfaces. And at some point I thought, wow, really? I can in Go just return any type I'd like to? So yeah, if I declare here interface, right, that means I can return any value, and that wouldn't be checked. And the only way to check it is to do it this type, how it's called, by the way? It's a type declaration, not type declaration.
Type hinting.
Type hinting. Oh, okay. Yeah, so indeed, I read that it's a bad practice in here, but that's the way how they use it in RxGo. Basically, they have these generic functions that can operate only on interfaces, and then you had to do this type hinting yourself in here. But
yes.
Yeah.
And while we don't have generics in language, we have to use such things. But I hope when we got generics, we'll be happy, much happier.
Yeah. Actually, also interesting, curious how it would look like. I didn't follow the conversation about that.
This interfaces was the. Sorry, Alex, to interrupt you.
No worries.
So I'm coming from a Python world, and this interfaces was something which kind of saved my day back in the day, because we were doing one of the projects in Golang. And yeah, I don't know C++ and all that kind of languages, and I was quite a bit shocked that in Golang you cannot simply read a JSON file. You have to know what you are reading, so you have to specify the structure beforehand. If you do not use interfaces, I suppose, because in Python you just load the JSON and then afterwards you can parse it and know what's inside. And I'm working with data, and I was quite shocked that in Golang you cannot do it. And it's so hard just to read a file. So
here is here is a little bit different pattern working with JSON or XML. Here is marshalling and unmarshalling, and it's something like mapping. It is not parsing of source files such as JSON or XML.
Yeah, so basically you have to know.
Basically, marshalling is parsing JSON, right, into the known type structures.
It is not parsing. It is marshalling. you get some variable and look this variable in struct in Golang. If you don't have struct, you don't get some variable, and it gets some intersections of structure and JSON, and it's just copy some data from JSON. It's not like parsing. It's a little bit different thing.
So is there a way in Golang to read the data which you're not familiar with, which you don't know the structure beforehand?
Yes, you could have some map with string and some other type. You could have map with strings because you know which keys you have, and you could have interfaces, and then you'll have any data. And when you parse JSONs with dynamic responses, you have to do a few times JSON unmarshalling and so on, and you need to have some anchors to get which data you have in next value to unmarshal it. And sometimes it's a really complicated task, and yes, but
that makes sense. Yeah. So sorry for from the main topic. I don't know.
Indeed, I was curious myself to know. Yeah. Okay, so I have just a few words left. I wanted to go through the code review, but I think we covered most of it. Basically, for this one, I implemented the node in here, and that was however, the function is not that bad and not that big in here. It actually the bad part of it is that it kind of communicates to the operator here. Well, not directly, it's based on this type hinting, how you call that. The idea is that you have to keep the stack, because the node part is called in this algorithm recursively. So you need to take care of the stack inside this piece of implementation. However, it doesn't have a direct idea on that, at least in the original function, in the original loop in here. Yeah, and then I have another improvement in the project itself. I introduced the GitHub Actions to test my code in here, and actually that's very easy. That's the first time I tried that, and basically you have to create the YAML file, which you can specify which versions you want to use for Go, for example, and then you basically run any test you want. So in this case, just run the built-in Go test functionality. It runs all my tests recursively, and yeah, you can see actually this is pieces of the IST tree in here in a string representation, and that's how it looks like with when it's stringified. Yeah, so now I have tests. Good improvement, I think. Yeah, actually I had them, didn't have them running. Yeah, and just one more thing about changelog. So that's currently version 0.03. I added a null denotation. So for the next one, and actually that's where I wanna ask our listeners, our guests today. So what should be our next goal in this PizzaScript project? I don't know, Igor, if you can share it to our YouTube chat. So I wanted to basically go to the next topic and produce the WebAssembly. So to make the parser step in that, sorry, make the compiler step complete. So to produce some well, not machine code, but like a WebAssembly code that can be already used in a browser, for example. So I wanted to continue working more in that direction to show the whole flow of this program. But for that, I wanted to extend a bit the current functionality, because right now it's just a calculator. It doesn't make too much sense to produce a Parsing modulus that just calculate some simple expressions, I believe. So I wanted to introduce variables, and for that I would need to do another step in here. So the main algorithm, I believe, is written, and I believe it works. However, if you check it with the other implementations of this Pratt parser, it misses one more, but important stuff, which is the expressions that you can use based on, not expressions, but functions that that are checked based on what operators they behave right now. So imagine you have yeah, I don't know, function expression. So you meet the this part, for example, this is PizzaScript, right? So you meet the function declaration in here, and basically every type of declaration that you have in a program input, you might want to have the custom definition of if it's valid or it's not valid, and that's how Pratt implemented the algorithm, basically. So that part is currently missing in here. It's partially in here, but it doesn't have the direct implementation. So how it looks usually, it's you have the associated functions. You usually store them as a prefix or infix parser functions, and basically those functions decide if this is a good expression or if it's a bad expression. So can I use plus with a string, for example? That already can be checked in this phase. So currently, I don't have the implementations of these prefix and infix parsers. I have just one small part of it, which is not direct in this structure. It's just checking the plus or minus on behalf of numbers, basically. But yeah, and I thought I will produce also WebAssembly modules with variables and small mathematical calculations in there. And one last important thing, I wanted also to get all my to-dos from here. There are a bunch of them already, and create a small issues on GitHub. So if someone wants to get their hands dirty in this piece of code, that would be highly appreciated, and we can continue next time. Then maybe we'll have talk together. But up to our listeners, by the way, yeah. So please vote on these forms. And last thing, RxGo. Yeah, was it a good choice? Thanks, Kirill, for your feedback. I also don't think right now it was a good choice. I think I still want to step to get some pause, and after implementing these variables, I will maybe have a better answer for that, because maybe I will have a way to encapsulate these functions similar to what we saw in this Wikipedia article. So maybe they will look alike, and in this case, my implementation would look simpler and would be more maintainable. But for now, indeed, I don't think that Rx ReactiveX patterns fit well to this whole project. But yeah, I still don't want to make the final conclusions about that. And yeah, that's basically it, what I wanted to share with you guys. I have some links. I will share them in our YouTube comments after all. Yeah, any other comments, any questions, any thoughts maybe?
Awesome, thank you, Alex. Thanks a lot.
Thanks.
Yeah, so I have a very high-level question. So you showed this online Bacchus Noir form checker or validator. Is it possible to create some service which will kind of produce the language for you? So you say, I want to have these Lexers, I want to have this BPs, or how you call them, these priorities, binding powers, yeah, and well, basically it, and then compile, and you have your engine for the language, or it will just simply doesn't make sense.
I thought you were asking about like the backward operation. You give this generator the examples of your language, and that would produce the grammars. I thought you were asking about that first, but I think the grammars are actually the easiest part. Not the easiest part, the easiest way of defining your language in here. So basically, yeah, it's not a difficult syntax. Yeah, it takes some time to get know it better. For me, first it looked not that straightforward, but I think that's the simplest way of defining your structures, basically defining your language in here.
Cool.
The other way, other examples, maybe there is an extended Bnf, but it's kind of the same. So I think you will do, in order to create a new syntax or new language, you will need to produce these rules. Maybe this one, or also, if I'm correct, that is called Markov definition of a language. I remember it from university. It's basically kind of the same, just a bit a different syntax of rules, but they are biactional to each other, this syntax and the other one. So I think you would need to make these rules in some way.
Mm-hmm. Cool, yeah. And maybe another thing, so, I mean, there are hundreds or thousands of languages, I don't know. So you are doing it more like for educational and fun reasons, right? But if the person is going to build a new language, which is going to be I don't know, industry standard or whatever, or there is an intention. So are there any standards that one should keep, the best practices, or it's super agile?
Yeah, good one. I honestly, I don't know the right answer for that. I looking myself into that. So I found many nice resources, and there are awesome books like language implementation yeah, there are many nice books by, for example, this Eintler author, like how to make your own languages. I didn't read yet the nice, super clear and straightforward resource about that. I know one awesome site that wanted to show is this one. I think I showed it already last time. So it has all many examples of combinations on syntax, how different languages use different operations and stuff. So yeah, I use it sometimes to choose what way I want to use in PizzaScript. Yeah, like integer, you can see here how different languages implement or not implement, what syntax they use to declare integers, for example, in their program. So yeah, if I find one, I will definitely share it with you guys.
Cool. Yeah, I suppose there is no one, because otherwise it will be only one language, which is
yeah. There are many resources. Yeah, it's a big list of resources, and yeah, it's almost infinite reading.
Yeah. Maybe the last one, I don't know. So your goal was, I think, to pick the funniest parts of the other languages. So
yeah.
do you have the list of all these, the most fun things?
Yeah, I keep it in this in my repo in our repo in GitHub. It's technology PizzaScript. So it has this. Well, README is just the one stuff, but the PizzaScript is basically the starting of a specification. Well, it doesn't look yet like that, but it has all the best I could make so far, like examples, syntax examples, some variable definitions, control flows. So I try to keep them in this document. For now, it will be here.
Cool. Thanks.
Right.
I would have another high-level question, maybe.
Yeah.
Really high level. If you you made a decision, you wanted to use the top-down algorithm, right, rather than the bottom-up one. When someone else now implements a language, why did you choose this? So what was your decision, and what would you recommend to use?
Nice, Basti, right in very sharp. Yes, actually, I'd like to, if I have a bit of time, I'd like to explore more the bottom-up parsers. The bottom-up looks like a better fit to RxGo. I think for now I haven't followed it completely yet, but what it looks to me, it could work better because it doesn't need this recursion in recursion, and as we saw, the recursion doesn't work well with this paradigm with the operators of RxGo themselves. So I thought I would maybe look into this bottom-up algorithms as a if I would do the alternative implementation on that. Yeah, I think the top-down recursive descendant, that's basically the simplest you can go with. It's in many sources I read that this is one of the simplest to implement manually, and basically. I think the bottom-up is mostly used in generated parsers. I'm not 100% sure. Yeah, so how to choose it? It's a very big topic itself, I would say. So that's
a good explanation. I like it. Go for what you understand, right? I also read that it's more powerful to use the bottom-up one in some examples. I don't know which examples this can be, but it seems to be in general and sometimes more powerful. However, when you say use what you understand, then I can totally relate to that, because I wouldn't recommend to use anything that maybe on the first glance everybody says it's better, but you do not fully understand it, or maybe you just for explanatory reasons you wanna use this one because it's just more straightforward. So I totally understand your choice here.
Exactly. Thanks.
Great.
All right.
Yeah. So seems like we're out of questions, or?
Thank you for your experiment. I wish you have fun in your language learning.
Yeah, thanks Kirill for being here. Maybe next time, if you don't mind, we'll invite you as well. So hopefully we'll see you next time as well. That maybe we're gonna speak more about WebAssembly. So yeah, I don't know how it's maybe relevant or interested in. Are you interested in that topic as well? Yeah, I'd like to thank everyone. Thanks for joining us for the next time. That's gonna be around 11th, I believe, 11th Saturday in 2 weeks. So we will have another session, I hope, and we're gonna announce it very soon. But please stay with us. We don't want to announce it right now, I think.
Probably not. But there's going to be definitely a webinar.
Yeah, some surprise, I would say.
Yeah. Cool, yeah.
Stay tuned.
Thank you. Yeah, Sebastian, Kirill, thank you for joining. Alex, thanks for the great talk. And
Thanks.
yeah, have a nice weekend, everyone. Thanks for joining us.
It was a pleasure.
Live.
Thank you.
Yeah.
Bye.
See you
Bye,
guys.
guys.